Hello everyone, welcome to my chemistry channel Bldash short and sweet in chemistry. Now the topic is fundamental concept of organic chemistry, that is actually for class 11 but very important for class 11 and 12 also. This is part 9 where I am going to explain hyperconjugation or no bond resonance. What is meaning? That means hyperconjugation, which is otherwise known as no bond resonance. Then what is no bond resonance? First we will see that is plus I, that is inductive effect plus positive inductive effect. Before that, we know in previous video that what is meant by inductive effect. There are two type of inductive effect. One is plus I, another is minus I. Then what is plus I? That means the substituent, the alkyl group, which can release electron tendency, that means here it gives tendency, releasing tendency. Releasing tendency of alkyl group mean here we can say electrons. Now when you come to our the topic hyperconjugation, here we can say releasing tendency of alkyl group. That means here in order the tertiary is more than secondary, then primary, then methyl. What is when tertiary? Tertiary means here alkyl groups are more. Here alkyl groups are more. Secondary, that is less than secondary, here alkyl group less, and primary only simple alkyl group, and last one is methyl group. If the last one is methyl group, what is the meaning here? That means this one is C2H5. Then if you compare that here, this is the highest tendency to releasing electrons. That means here you can observe CCA3 whole 3, and here it is 2 methyl group. Here it is simply ethyl group and simply methyl group. Then here methyl group is the least tendency to release electron when you compare to tertiary where 3 methyl groups are present. When alkyl groups are attached to, if suppose the alkyl groups are attached to any one, which one? That one here, to an unsaturated system. That means if alkyl group, you know, it has tendency to release electron. If more alkyl group, more tendency. But if you say, if it attached to unsaturated system, that is double bond, and what happened here, especially in double bond, it occurs. So it is example as CS double bond CS2. See, here double bond is there, and this side that is your what is that one? This side alkyl group is attached. Either one alkyl group or 2, 3. It depends on the nature of the compound and what is the nature of the alkyl group present in the particular compound. That means here what you observe, releasing tendency. See what before unsaturated system, what is the releasing tendency? If more alkyl group, more tendency. But here if unsaturated system is attached, and then what happen? It is reverse. That means releasing tendency is reverse. Reverse means the opposite. Then indifferent from inductive effect. So you can see here inductive effect is totally different. And are you clear? If the alkyl group simply present, then if more alkyl, more tendency to release electrons. When unsaturated system, just like this, C11C or as CS11CS2, and this side any alkyl group is attached here, this side any alkyl group attached, then what happened? The tendency is reverse. Hyperconjugation is a general stabilizing interaction. That means due to hyperconjugation, the stabilization occurs. That is permanent effect. So it is called permanent effect, because hyperconjugation gives the idea, gives the value of stabilizing, and that's why it is very important and very permanent effect. When CH bond is attached to unsaturated system, the double bond. See here, this is CH, it attached to double bond. Then what happened? Unsaturated system double bond or benzene ring. You know benzene ring alternative sigma and double bond present. Then what happened here? That means if the CH group, CH simple, CH is attached to unsaturated system double bond, then what happened? That means your benzene say then interact with the unsaturated system. Then CH bond interact with the unsaturated system. That means if CH bond is attached to a double bond, then it will interact with the C double bond. The interaction between the electron of pi system. Multiple bond, that is double bond is a multiple bond where one is sigma bond, and other one is pi bond. Then what happened here? Then here the interaction between the electrons of pi system. When there is a double bond, there is a pi system, that is a pi bond. Pi bond means the free electron here on the pi, that is called pi electron. And the adjacent sigma bond, now it is CH. CH is attached to double bond. That means here, how can you write? The CH attached to double bond. That means CH2. What happened here? The interaction between the electrons of the pi system. See, this is the pi system and this is the adjacent bond. Adjacent bond which is the sigma bond. So, of the stabilized group is called hyperconjugation. That means the reaction between the electron of the pi system here, this one, and interact with the sigma bond of the adjacent carbon, this one. It is called hyperconjugation. A hyperconjugation that is developed by Becker and Nathan, that is called Becker-Nathan effect. Then question is how it is proceeding. What is the nature of the hyperconjugation? Now see in detail. Till now what you understand? If the CH bond is attracted to the unsaturated system double bond, then this is the example. Now this electron, pi electron, interact with the sigma bond, that is very strong bond CH here, and then what happened? The stabilized group is called that is hyperconjugation, and it is called Becker-Nathan effect. And alkyl group, then question is alkyl group simply. Now till now what I have said? This portion. That means here I say CH double bond CH. CH double bond CH, CH2. See, this part I told. But it said if the alkyl group attached to an unsaturated system, now this part if attached to the CH double bond CH2, then what happened? It release electron, the carbon hydrogen single bond. It release electron, this part. This here release electron to the carbon hydrogen single bond, that sigma bond towards the this side not, this side only. See, here also sigma bond, here 3. This fourth side that is having sigma bond. So here what is saying? Here only the release electron from carbon and hydrogen towards the single bond, that means towards the multiple this side. So what happened here? This electron, suppose methyl group is attached to CH2, that we will see one by one about first methyl group, then ethyl, then other further increases the alkyl group. Then what happens? Now simply CH3, CH, CH2. CH double bond CH, what is the name? This is called propene. So you can say, you can observe here in propene what happens. First of all, this pi electron, that means comes very polarized one, that is where it comes towards the CH2, last one C, the carbon. Then if it comes to carbon, then what happens? It occupies negative charge with this pair of electron. You can see here the negative charge with pair of electron. What happens here? Here the a pair of electron of sigma bond, which is very strong one, that is localized to the next bond, sigma bond, towards multiple bond this side only. Then what happened? It remains as a free one. See here H plus. Now there is no bond because due to hyperconjugation, this electron pair released towards this carbon and this carbon, so it is having double bond. See here and here, what is the comparison? This pair of electron localized to the sigma bond, and this pi electron, that bond that is localized to this carbon. That is why the H plus ion, which is freely present here and having double bond, and this one double bond changes to single bond, and here pair of electron with our one negative charge. There are two types here, two existing. Then come to now this carbon has 3 hydrogen atom which is having sigma bond. That means from here electron can localize to the, here you can see this diagram, this structure where the electron moves towards it. First this one moving, and second this one, third this one. Out of 3, one by one, it is not sure that this is first, this is second, third. Anyone you can take as first, the second, then third, like this, first, second, third, anyone you as you like. Though what happened here? Here also, instead of heat, here this one is moving. This hydrogen and carbon having sigma bond moves to here. That is a double bond. Similarly, second case, what happened? This is remain as it is, and this part is moving, so it becomes H plus, which is having no bond. See, remember, resonance occurring here. You see here resonance occurring, but there is no bond between H plus and C. And similarly, third, fourth time also here you can get. This is the original one, and this is first, second, third. Why third? Why 3 structures are possible here? Because 3 hydrogen are attached to carbon as methyl group. Methyl group, 3 hydrogen are there. One by one, they can release electron towards the never single bond, and from double bond, it goes to the never carbon having negative charge. This is negative charge, and here what happened? And having a pair of electron. So this is called resonance, hyperconjugation effect of propene. Now the hyperconjugation forms are called contributing structure. Now before, see here 3 type of structures. One is original, and second one is 3 structures are produced, that is called contributing structure, because only due to movement of electron, localization of electron from hydrogen to the never carbon hydrogen bond, and that is what is called contributing structure. And now see CH3, CH2. Why only 3 hydrogen have of alkyl group, that is methyl group, are behaving as the contributing structure, where there is no bond resonance, only H plus sign is there in 3 times the structure. And here this is called alpha hydrogen. From here you will not count, because it is one that is unsaturated system. It is one unsaturated system, and this is called alpha part. So how many alpha hydrogen are present? 3 alpha hydrogens are present. 3 alpha hydrogen mean 3 structures, including the original structure, or the 3 structures are there where they behave as contributing structure. Then what happened here? This is called alpha hydrogen. Why alpha hydrogen? Because it is called alpha carbon. If hydrogen, how many hydrogen are attached to carbon? Alpha carbon, they are called alpha hydrogen. Pi electrons, you know there is a double bond. CH3, C. This is the pi electron of double bond, make the cleavage of CH bond. Then what happened here? How it will cleavage? See here, make up the cleavage of CH bond in methyl group. That means in methyl group, how many alpha hydrogen? 3 alpha hydrogen. Only due to presence of unsaturated system, or you can say presence of pi electron double bond, only that is due, that helps to break the bond CH. How many times? 3 times, because 3 alpha hydrogens are there. But since it is localized to the never sigma bond, that is why it exists as H plus, and there is no bond between CH. How many times? 3 times. See here propene 3 times, so it is called cleavage of CH. How many times? 1, 2 and 3, because 3 H plus are produced in the structure, so that is why it is called the cleavage of CH bond of methyl group. Hyperconjugation is similar to, when you observe that what happens here, and what happens here, and now our resonance structure. Now you can find a totally similar structure, but in our resonance effect there is no meaning of alpha carbon, alpha hydrogen. That is why there is no bond between, when it produces the contributing structure, you can find there is no bond between alpha carbon and alpha hydrogen, so it is called no bond resonance. When you observe in resonance effect, there is no alpha carbon, there is no alpha hydrogen role, and there is no H plus effect, H plus idea. But here, since alpha carbon and alpha hydrogen are there and no bond is there, that is called no bond resonance. It behaves as a resonance, but actually it is called no bond resonance because simply H plus is there and there is no bond. Greater the number of alpha hydrogen atoms. Suppose 3 alpha hydrogen in methyl. In ethyl, how many? 5 alpha hydrogen present. So more reluctant tendency you can see where more. One is methyl group, 3 alpha hydrogen. One is ethyl group, 5 alpha hydrogen. So which has more releasing tendency, that is ethyl group. Example, number of alpha hydrogen atoms in methyl group is 3. You can observe in methyl how many alpha hydrogen present, because CH3. When CH3 is attached to, where it attached? CH double bond CH2. This one is CH3. So you can find there are 3 alpha hydrogen, and here that is more. Or when it is ethyl group, I told before also, when ethyl group, how can you calculate that one? Because alpha hydrogen in ethyl group, see, count here. This is 2, this is 3. That means this is the position of ethyl. Though there are 2 carbon, there are 2 hydrogen and alpha carbon, and it is beta. It is alpha and it is beta. And here it is counted unsaturated system. That is why it is counted as simply one unsaturated system. CH double bond CH2 act as one, and after that this is called alpha hydrogen and this is called beta hydrogen, because this is beta carbon, it is alpha carbon. So now you count how many hydrogens are there. This is only 2. Sorry if I said C2H5 alpha hydrogen is wrong, and it is only because this is act as a beta carbon, this act as alpha carbon. Only 2 hydrogen atoms are there. Here there is no 5 alpha hydrogen. Again you see properly, it has 2 alpha hydrogen. In methyl group, what you observe? 3 alpha hydrogen. In ethyl group, how many alpha hydrogen? 2 hydrogen. So the number of alpha hydrogen atom in isopropyl group, isopropyl C, and this is again one system. This act as one. It is one system, so onset system, and this is called alpha. Since it is alpha, these are the substituent. Now you can observe how many hydrogens are there? Only 1. In isopropyl group, there is only 1 hydrogen atom, and ethyl group, how many? There are 2 hydrogen atom, and methyl group there are 3 hydrogen atoms. The number of alpha hydrogen atom in tertiary is 0. In alpha carbon there is no hydrogen. So what is meaning? The alpha hydrogen is 0. Again see, in methyl group there are 3 alpha hydrogen, and ethyl group 2 alpha hydrogen, and isopropyl group only 1 hydrogen alpha hydrogen, and tertiary there is no hydrogen atom. Now if you see the example, and what happened, the order of hyperconjugation where the CH3 is more than ethyl group. Methyl group has more the hyperconjugation than ethyl, then methyl. If methyl is more ethyl, then isopropyl, then tertiary. Are you clear? Now here, how many alpha hydrogen present in the particular structure you observe, and counting as unsaturated system as one part, and after that it is alpha, beta, gamma like this. You can find here In methyl group, this is 3. In ethyl group, this is 2. And isopropyl, this is 1. And here there is no hydrogen here, you can observe. That is why methyl group is more than ethyl, more than isopropyl, more than trimethyl group. Hyperconjugation occurs through alpha hydrogen. Now what is the conclusion? What you observe here? Hyperconjugation always occurs in alpha hydrogen. Alpha hydrogen atom, where it is attached to the carbon, that is called alpha carbon. And where it is present? The present is in the carbon next to double bond. Double bond mean here I have explained CH double bond CH2. This part is called unsaturated system, or you can say double bond, and here something is attached. What is that? Alkyl group. In alkyl group, you observe what is the number of alpha hydrogen atom that particular alkyl group. Again I want to say methyl group is the most, that is 3, and ethyl group 2, and isopropyl 1, and trimethyl, that is tertiary, has no alpha hydrogen. So indirectly you can say CH3 has more hyperconjugation than CH3 CH2 when attached to the unsaturated system. Example, CH double bond CH2. This part, this is very very important. It is attached to CH double bond CH2. And CH3CH2 has hyperconjugation less than isopropyl. That means methyl group has 3 hydrogen atom. That is why it is more than ethyl. Ethyl group has more hyperconjugation when compared to dimethyl. That means here you can say isopropyl. That means here only 1 hydrogen. And when you come to next, what is the example? That is tertiary alkyl group. So our tertiary alkyl group has no hydrogen, so no hyperconjugation. Then what do you mean by orbital concept of hydrogen? Orbital concept means you observe one side there is a double bond, that is called unsaturated system, and other side that here alkyl group attached to the carbon, where this carbon is attached to double bond. Now you can observe here pi electron mean here what happened? The unpaired electron present in the that is p orbital, and here this is sigma bond, sigma. And what happened here also? The sigma bond, that means here observe that is interact with the pi electron, pi bond. Hyperconjugation here takes place when the electron pair of CH here, electron pair of CH bond conjugated with the pi electrons of the double bond unsaturated system. Then this part, this is the part, and this is the part where both are interacted. Then here hyperconjugation involves delocalization of sigma bond. Here hyperconjugation, in hyperconjugation what happened? This is the sigma bond electron that delocalize to the through the overlapping process to the double bond. Through the overlapping here, what is the overlapping here? Pi overlap, p orbitals of the double bond. Here sigma bond, the electron delocalization of sigma bond of CH bond, that is overlapping with the p orbitals of the double bond. And now you see this is a little bit difficult, but try to understand how the orbital overlapping, orbital concept says that this one involves in the localization of the sigma. Is this sigma bond? This localized and through the overlapping structure of the double bond. Here double bond present, here p orbital present, and here sigma bond is there, and how it will delocalize and form the hyperconjugation. And when you see here, you can observe this one as CH, H, H. This is also H, that means methyl group, and this is sigma bond. This is sigma bond. Sigma bond means that is Here CH3, that means here this part is your sp3 hybridization, and here simple present. This is C, and here what happens? How the double bond is produced, that is the pi electron. How the pi electron produced, that is py pz overlapping, and that is two lobe structure. And then here this electron and here p orbital contain also electron, they what happen? They delocalize, localize sigma 1 and pi 1. Then it is called through the unsaturated system. Again see, this is the CH out of CS3. When you write CS3, see, when you write CS3, this one and these three hydrogen are present, and they are all sigma bonds. Now what happened? Here, suppose this one undergoes your hyperconjugation, this electron will jump, will localize to this sigma bond. So what happens here? And this is a sigma bond, where this side what happened? Two orbitals are there, where they form two lobes and pi bond. Now what happens here? Since it is sigma bond, and here this is the hyperconjugation takes place between this one. Here also p orbital present. Here also p orbital present. And this one interaction between this pi bond and here this is called, since it is sigma, so it is called sigma pi hyperconjugation, because sigma localized toward the pi bond, that is called sigma pi hyperconjugation. And here on this part is unsaturated system. So what happened? Again see, CS is the double bond, that means here this is the CH, that is a single bond, that is sigma bond, strong bond. Are you clear? And this side PYPZ, that is overlapping, lateral overlapping, forming pi bond, and this sigma and this pi, and their hyperconjugation takes place. So I think this is the structure here, this one, because interaction between this one and this, so it is called hyperconjugation, that is orbital concept. Then if you will come to this one, here you can observe possible in organic compounds with positive charge. You know, so many organic compounds in the reaction mechanism was you observe, and that having positive charge. What do you mean by positive charge? Positive charge means loss of electron, less of electron. What is the number of electrons should be not present, that is less than that, that is called cation. Carbon which occupies positive charge due to any method, any process by losing electron, and that is called cation. Now if you take ethyl group, and that is called ethyl cation. Cation means now it is called carbonium ion. And CH3CH2, before that there is no plus charge, but here it is a plus charge. Then what happens here? So one electron less, that is why here this is the same as before our when there is no plus charge, simply hyperconjugation in methyl. If it is a methyl group, now see this methyl group, and this is all are sp3 H hydrogen, that is s orbital, and this is the hybridization of sp3, and that is why this side also that is having touch with the, that is bonded with this carbon. And here in ethyl, you know, there are two hydrogen present in first, here in alpha position, when it is attached to unsaturated system. When it is attached to unsaturated system, then what happen? Here see, and this is the hydrogen overlapping, that is sigma bond. This is sp3H overlapping, that gives what? Sigma bond. Everywhere this one sigma. How many sigma? 3 sigma, that is 2 hydrogen. Now this orbital and this orbital, when one electron less, and this is called hyperconjugation, and here empty orbital present because there is loss of electron is not present here, occupies positive charge, that is empty orbital to p orbital. So this is the hyperconjugation in a cation. What is cation? That occupies positive charge, and here ethyl cation, or you can say carbonium ion. So this is the orbital overlapping of the orbital concept of the hyperconjugation. Then in ethyl cation, what happened? Very important. In ethyl cation, what happened? What is ethyl cation? I told, if CH2 group is attached to positive charge, then it is called ethyl cation. In organic compounds, where we can see if carbon occupies carbon atom, with example here you can see CH3 CH2, CH3 CH2, and here it is positive charge. What happened here? It is positive charge. If positive charge, that is called ethyl cation. So here positive charge. And now in ethyl cation, one of the CH bond of the methyl group can align in the empty p orbital. So I told in our this part CH2 group there is a p orbital which is empty, and here this is 3 hydrogen present with 3 sigma bond, that is overlapping of sp3s orbital. What happened here? sp3s. So what happened here? CH bond methyl group align. That means there is same plane with empty orbital and electron constituting CH bond in plane with the p orbital. So in the same plane, that is in p orbital, it is there, so delocalize into the empty orbital easily. So electron from here, the sigma bond, and that is delocalized to empty p orbital. Here hyperconjugation due to partial overlapping of sp3s. One is CH bond. How many CH bond? How many alpha hydrogen? 3 alpha hydrogen. 3 alpha hydrogen mean 1 sp3s. Similarly, how many? 3 CH bond is produced by overlapping, partially overlapping. With empty p orbital, then here 1, that is with empty p orbital of positive charge of carbon atom in which position? In CH2 position. In CH2, that carbon having positive charge and having empty p orbital, that is overlapping with, partially overlapping with sp3s, that is CH bond. Similarly, that is only one position occupies. There are 3 alpha hydrogen, 3 CH bond, 3 sp3s overlapping partial. And what happened here? This one having partial overlapping with empty p orbital of positive charge of carbon, that is in ethyl group, that CH2. So here hyperconjugation in CH3 CH2 plus, you can see once this is the main important one, that is first, that is your CH2 plus. And how many alpha hydrogen? 3. Sorry, beta hydrogen 3. So when you compare to this here, what happens? If you attach to the that is double bond on such a system, then it is alpha, this is alpha, this is beta. But now in simply CH3 CH2 plus, then what happened here? This is the sp3 s overlapping each one. This hydrogen, this hydrogen, this also, and that is partially overlapping with this carbon. When carbon what is present? that one empty p orbital. This is called partially overlapping. So one hydrogen first, that is H plus, and second H plus, and third H plus. Because here it is in compared to this CH2 plus, this is alpha hydrogen. But when it attaches to CS double bond CH2, and then it is alpha hydrogen. Now it is ethyl carbocation, ethyl cation, and this is alpha. So how many alpha hydrogen? 3 alpha hydrogen. Then how many H plus for no bond resonance? How many? 3 times. This is 1 time, and this is 2 time. It is 3 time. So here, since 3 H plus ion produced, and then what happened? It depends on the stabilization of carbocation due to electron density from sigma bond. You know where sigma bond present, and here what is the electron density? It is a strong bond and dispersed with the positive charge. See how many sigma bond are there? This one. And how it will affect to the plus sign, plus charge. So it affect to the plus charge, dispersed to the plus charge where? In CH2. So stability of the carbocation decreases when there is CH3. How many CH3? And C having plus charge. So here when the alkyl group is more, stabilization of carbocation decreases towards our CH3 group. So tertiary more stabilized than secondary, then the CH3CH2 group, then CH3 group. That means here more alkyl group are there, more electron can disperse to the positive charge, and that is why it is more stable. And here you can say stabilization depends on the charge. You can observe CH3 whole 3 C plus is more stabilized than CH3. This one CH3, not CH2. So it is CH3, CH2. If it is CH3, this is CH, inside it CH3. And here application of hyperconjugation. Since there is a partial overlapping takes place between carbon single bond, that is sigma bond, to the p orbital, empty p orbital in carbocation group, that is example ethyl cation, then here shortening of carbon-carbon bond, single bond, adjacent double or multiple bond, that is that bond length short becomes short. So shortening of carbon-carbon single bond adjacent to multiple bond is there. If it is attached to multiple bond, then what happens? The length is shorter. Then here, if you see, you can observe, I told also before, CH3 group, there is alpha carbon and alpha hydrogen. This is localized to this one, and this one goes to here. This one goes to here. This carbon, so what happened? H plus produce, and here, then here the bond length become less. Similarly, if you say, this one is, and this one becomes to single bond, this one also single bond, this one also single bond, and here this becomes double. So again you have to correct this one. So see here, what is the correct one? Since the bond here, the sigma electron localized here, it becomes to double bond, and here it is becomes to single bond. So double changes to single bond. And see what happened here, the correction work is there, double changes to single changes to double. Then you can see, since they localize to this side, so it should be double, it should be single. And here it is correct, it is also correct, and here it should be double, it should be single. And this is the Hyperconjugation example OH CH11CH2, that is propene. So similarly, other examples also, it can explain the stability of the carbocation and free radicals, what one can read in organic mechanism, and also carbocation, carboanion, what is the meaning, and I hope it is clear. Again, see, hyperconjugation, that is called no bond resonance, and that is developed by Becker and Nathan, so that is called Becker-Nathan effect. And orbital overlapping also very important, but it is little bit difficult, and try to understand here. And I hope you will subscribe my channel Bldash, short and sweet in chemistry. Thanks for watching my video, Bldash.